Welcome to the lecture, Introduction of Automotive Spice. In this lecture, we will talk about basic ASPICE framework and make the intro for going deeply in separate ASPICE processes in the next lectures, like management process, like supporting processes, like engineering processes in the left and right side of V. In previous lecture, we mentioned what are the process models. Automotive SPICE is one of the most used and widely recognizable process maturity model for assessing and developing the embedded software in the automotive industry. SPICE stands for System, Process Improvement and Capability Determination. And this is basically really the abbreviation of those terms. In the automotive industry, the original equipment manufacturers, OEMs, and suppliers use automotive SPICE to manage their product quality and their project success better. The legal owner of the brand Automotive SPICE is Quality Center of the Germany Association of the Automotive Industry, VDA. Similar to any process maturity framework, Automotive SPICE consists of a process reference model, PRM, and a process assessment model, PAM, tailored to the needs of developing electronic devices in autos. As of version 3.1 of the standard, it is possible to add further engineering disciplines like hardware or mechatronics and the corresponding domain-specific processes to the scope of automotive SPICE. And depending on the product to be developed, you will add those parts to the automotive SPICE as you need. This concept is called plugin concept. The plugin concept is part of NXD of the official standard, and it is represented through 4 mini-V models. Processes such as management processes and supporting processes are domain independent and designed in a way that they shall be applied to both the system level and the domain levels. The top level comprises all system engineering processes organized in the system way. Depending on the product to be developed, the corresponding engineering disciplines with their domain-specific processes like hardware or mechanical engineering and software engineering can be added to the assessment scope. The dark blue boxes on this picture are representing VDA scope, and they are part of Automotive 3.1. Automotive SPICE 3.1. Other gray areas are not developed by VDA, and they're used in a similar way, but they are not really the part of the standard. In the early 90s, in the USA, the first process model which was created is called Capability Maturity Model, or CMM. After almost 10 years, it is developed more to be used for modern cars. The version developed and released at 2000 was called Capability Maturity Model Integrated, or CMMI. CMMI had two successors, one in 2006 and the latest one in 2018 with the version 2.0. In the meantime, in Europe, in the 1998, the first new standard appears called ISO 15504. In 2008, the standard received new Chapter 7 assessment and was developed for checking the compliance. After 7 years, new standard appears, ISO 3300X. After 7 years, this standard was basically only explaining the assessment parts. But All the standards were triggered by big OEMs, which formed the Automotive Interest Group, who developed first version of SPICE for automotive in 2005. The latest version, which is the scope of this course, has version 3.1 and it is developed in 2017. The standard is now the fact most for automotive business, and it is used widely as something which is the must for more than I don't know how many companies, but now most of the companies are using it for basic framework. The key concept of automotive SPICE is two-dimensional framework. The 1X is process reference model, which is describing domain and scopes, process purpose and outcomes for each process. Other dimension is measurement framework taken from ISO 33020. This X is determining capability levels, process attributes, rating scales, and methods, and process capability level model. About both of the scales, we will talk about later in the lectures, but the key aspects of this concept of the automotive SPICE is that each of the processes can be for sure measured separately, but without having them in the operating mode that all of them are working together, you cannot have the mature process model like automotive SPICE. Furthermore, key concepts of automotive SPICE are summarized in this part of the lecture. Concept that we need to use qualified input to aim quantified output means that exact expert shall perform the work using qualified input and shall provide qualified output to the next one in the value chain. This can be achieved by dividing the work into small tasks and getting the tasks done continuously, one after another. Qualifying and approving the work products continuously means that by using those finished tasks, you will, of course, have continuous work, but you need to approve those steps in some way using some very clear criteria and efficient method to qualify. Next, the concept of agree and summarize means that on engineering processes, requirements, and design must be agreed in between all involved parties, and that all results of verification must be summarized and further communicated. On the management and supporting processes, all strategies like plans and schedules must be agreed, and that summarize of the progress must be done regularly. Then we have divide and control, which means that on system, domain, and subdomain, and of course component level, we need to specify and design the solution. We need to delegate to lower level or implement solution on unit level. Integrate and verify integration against the design before qualifying the solution against the specification. And the last but not the least is concept of traceability. Traceability means that each item, requirement, design, element, implementation, test case, result, or finding must have a reference to its source and to its verification. The traceability is used as a last term, is used to check for consistency, to analyze its impact, and to show competencies. Now we are coming to the most important part of this lecture, and this is the SPICE process model. Here you can see that a SPICE is organized as follows. You have the system part, you have the software part, processes. Then there are management processes and supporting processes divided into blocks. You have the acquisition process group and the process supplier process group. Then you have reuse and improvement processes. In each of the blocks, you will find the specific processes which are describing not only the steps, but which are describing what are the basic outcomes that needs to be delivered to receive some kind of value of each of the processes. For example, in the system a process group, elicitation and management of customer and internal requirements, definition of the system architecture, and integration and testing on the system level processes is described. And you can see that in the blocks from SIS1 till SIS5. Then you have this software, as I said, engineering process group, and management of the software requirements, development of software architecture and design implementation, integration and test of the software are described here. You have in overall 6 processes which are explaining how software should be developed. In the management process group, you have 3 processes like project management and risk management and measurement. And those processes may be used by anyone who manages any type of project or processes within the life cycle. It is not important that the project should be automotive. It means that those are the basics of the project management. Then we have this supporting process group, and the supporting process group has 7 processes which are describing how we will support the engineering area to reach the desired quality of to be organized by using some specific configuration management. Processes that may be employed by any of the other processes at various points in the life cycle. Those are the supporting process group. In the acquisition process group, we have the processes which are mainly performed by the customer or by the supplier as customer of these suppliers. Then we have this process performance by supplier in the supplier process group. And the 2 groups which I mentioned, reuse processes and improvement processes, which are used for the higher level of the automotive SPICE. All of those processes which are important for developing the automotive projects will be explained later on through the next lectures. This is the one of the examples that I wanted to show you how the processes in automotive are organized. This is, for example, the core project management process with best practices and work products. And every process in the automotive SPICE, as you can see here on this slide, have basically process reference model and process performance indicators. The process reference model consists from process ID, and this is the, for example, month 3. Then process name, it is project management, and it is a unique name. Then process purpose, which is explaining for what we need this process and why this process is basically part of the automotive SPICE. Then what are the process outcomes? And this process reference model is basically telling you how to organize what is the minimum for having this project management process, for example. In the same way, all other processes are organized, as I already said, in this way. Then we have process performance indicators. Those process performance indicators are called best practices and output work products. And when you're looking into the process assessment module, which is formed from the best practices and output work products, you will realize that here we have some kind of checklist how you can basically track did you perform your process well. All those steps are not mandatory to be fulfilled, which are described here in the base practices, but they will for sure be checked while performing the assessment. It means that you're not in obligation to have all the listed best practices in your company, but you're in obligation to have these 7 outcomes listed here. If you want to use any kind of mapping to the ASPICE direct mapping, like it is listed here through this, let's call it checklist, you're free to do it. Then you have these output work products that I already mentioned. Those are the basically really things that you need to deliver to your customer or to deliver from this process. Now let's zoom in and what are the work products? Well, here you can see that basically the work products that I mentioned on the previous slide are listed on each on each process. In the first example, when we had project management, we had different types of the output work products. Here I just zoom in and, for example, quality assurance process. And why we need those work products? Basically, work products are sets of characteristics that would be expected to be evident in the work product of generic types as a result of achieving of an attribute. And here you can see in Annex B of Automotive SPICE, you have the list of all work products which are mentioned through the Automotive SPICE. You can see that, for example, this extraction from the quality assurance sub-1 process, which I marked here as a quality plan, is also listed in that list here. And that basically all the characteristics of that quality plan are described very in detailed in the work product characteristics. These work product characteristics can be used for help while you're developing quality plan. But this is very specific plan, quality plan. And you can see that this quality plan is marked with ID like 0813. But there is also one generic work product called plan, which is listed like a 0800. This plan is work product which is summarizing all the basic and generic things which are necessary and characteristics which are necessary to be part of one plan. And later on, we will talk about more about having more levels of automotive SPICE. But here I just wanted to summarize that in the base practice 1, in the most of the processes, you will find something like develop strategy. And the develop strategy means that you need to have the quality plan, that you need to have project plan, configuration plan, and similar. And in the level 1 of automotive spice, for the very basic automotive spice usage, you will then use this specific like 0813 quality plan for quality assurance. But for the higher levels, when you want to achieve more organization and more managing processes, you will then include this generic plan, all the characteristics from the generic plan, and or the characteristics of quality plan or some other specific plan. Now let's observe again one of the example processes. And in this example, we will try to apply the process elements on the example. For the first part of this, let's say, practice, we will say that for the process improvement, we're using those parts of the processes in the way that we can answer on the certain questions. For the what benefits does this process offer, we are basically answering by reading the process proposed. Then, by reading the process outcomes, we will answer the question, what are the typical results? Then, in the section based practices, we will answer the question, what are the expected practices to achieve the proposed? In the output work products part, we will then easily answer to the question, what are the typical artifacts? By going back in the first picture that we said, there is also PAM, process assessment model, we will answer on the different questions by zooming in the same areas of the process. Then we will answer on the question, to which degree is proposed achieved? Then, do the outputs provide sufficient evidence? And how effective is the implementation of this practice? And do the work product provide complete information? Why I divided these two parts? It is because the first one, the green one, is basically referent model and how we will do the improvement of the referent model in our company. And the blue part is basically leading us to the answers or the questions, of course, which will be asked in the assessment of automotive spice. Now we want to understand the level of abstraction of process assessment model. The term process can be understood as 3 levels of abstraction. These levels of abstraction are not meant to define a strict black or white split, nor it is the aim to provide a specific classification scheme. The message here is to understand that in practice, when it comes to the term process, there are different abstraction levels, and that process assessment model resides at the highest. What? Allspice is very strict when it comes to the terminology. But be careful because this terminology is not fully aligned with ISO 26262. In the Allspice, the objects of the left side are called elements. Each architecture element is called component, and all the components are composed of some components or units. In the right side of V, all the objects are called items. On the lowest level, we have also verification items, which we may call units. In the ISO 26262, Item is a system or a combination of systems to which ISO 26262 is applied. That implies a function or part of a function at the vehicle level. System is a set of components or subsystems that relies at least at one sensor, a controller, and an actuator with one another. And component, which is fully different than ASPICE terminology, is non-system level element that is logically or technically separable and is comprised of more than one hardware part or more parts or software units. Now we're coming to the very important aspects of automotive SPICE. This is also part of Annex D of Automotive SPICE as the terminology and other important aspects. Here we have on this image the traceability and consistency of each of the processes in Automotive SPICE. Traceability and consistency are addressed by two separate base practices in the Automotive SPICE 3.1 process assessment model. Traceability refers to the existence of references or links between work products, thereby further supporting coverage, impact analysis, requirements, implementation, status tracking, and similar. Consistency, on the other hand, addresses content and semantics. Furthermore, bidirectional traceability has been explicitly defined between test cases and test results, and of course change requests and work products affected by these change requests. An overview of bidirectional traceability and consistency as on this picture, as you can see on this picture, is that basically all the lines or the arrows which are written here, drawn here basically, are defining bidirectional traceability and how it works. For example, we have some customer requirements or some stakeholder requirements. Those stakeholder requirements must be traceable to the system requirements bidirectionally. And the consistency, this is the red sign here, explains how those two stakeholder requirements and system requirements are consistent. Then on the lower level, these system requirements must be decomposed in the way that software requirements are fully aligned with the system requirements and that they are consistent. In the middle, you have system architecture. The system architecture is defined on the basis of the system requirements, and it means that they need to be bidirectionally traceable and consistent. Furthermore, on the lower level, in the software part of the main model, we will have software architecture, which is of course traceable to the software requirements, and lower to the detailed software design, and of course software units. You can see that there is a connection also between software requirements and software units, and that this arrow is pointing from the software requirements to the software units directly. It means that both of them needs to be compliant with each other. And they need to be consistent, of course. This is basically the whole left side of the V. But on the right side of the V, all levels which are explained on the left side are of course, tested by the separate test processes. In the lowest level, we have static verification, which is used for testing the software unit. And then we have unit test specification, and in the higher levels, you have, of course, integration test specification on the software level, qualification test specification on the software level, and both of them in the same way on the system levels. Beside the specification and the testing results, and of course the testing which needs to be fully bidirectionally traced with a left side, we have also the results which needs to be traced to those specifications. On the end of this lecture, we will mention evaluation, compliance, and verification criteria, which are really very important aspects of automotive spice. This part is also part of Annex D of Automotive Spice. Basically, verification criteria are used as input for the development of the test cases or other verification measures. Verification criteria are only used in the contents of requirements analysis processes and unit verification. Verification aspects which cannot be covered by testing are covered by the verification process called Sub 2. Evaluation according to defined criteria or alternative solutions is required for system and software architecture as well as for software detail design. Such evaluation criteria may include quality characteristics like modularity, reliability, security, and usability, or results of make or buy or reuse analysis. The evaluation results, including rationale for the architecture design selection, has to be recorded. Then compliance with an architectural design means that the specific integration tests are capable of proving that interfaces and relevant interactions between the software units, the software items, and system items fulfill the specification given by the architectural design. As in the previous lecture, I will not give you immediately the exercise. We'll do that through the live sessions. But I want from you to think about the minimum processes which are necessary for the project. For example, from the medium-sized project developing software. Then try to discuss or think about what will happen if such a project receive some kind of change request from the customer. And by knowing all the terms and all the necessary traceability in between processes.